So this is problem number 3 for the continuation of the previous video, no? So meron daw tayong force of 150 pounds applied to the edge of the member shown. So notice that ito yan siya, yung 150 natin is dito naka-apply sa gitna at 2 inch from this edge and then 5 inch from the center. Okay, 5 inch from here to here and then 2 inch from 2 inch from here to here. Okay, so neglect the weight of the member and determine the state of stress at points B and C. So dalawa yung points natin. We have points B and point C. Okay, so ang loading natin is not an actual load kasi hindi siya naka-act sa ating centroidal axis. Okay, so ang tendency may ma-create dyan na moment, flexural bending stress sa ating cross-section. As well as, obvious naman na meron tayong axial na internal load. Okay, due to the vertical na load na 150. So pag-cut natin sa section na to, sa section BC, ang makikita natin is ito. Okay, itong section na yan. And by summation of the forces vertical, yung force natin na nag-a-act, ang concern natin kasi is doon sa centroid. Doon sa centroidal axis, kukunin yung axial internal load at saka yung moment. So sa yung moment na din yan is about the centroidal axis dapat. Okay, so this is by summation, that is 150 pounds. Yan ang ating normal force. So 150 pounds by summation of forces along V yan equals to 0. Okay, and then ang moment naman natin is ipa-moment lang natin yung 150 dito sa centroidal axis. So, gaganon siya dyan with this moment arm, which is 5 inch. So, you will have 150 times 5 equals 750. So, ang unit is pounds inch. Okay? Then, due to these internal loadings, meron tayong stress na mararamdaman ng cross-section natin, and that stress is a combination of normal stress due to the normal force and then flexural stress due to the bending moment. So due to N, or tawagin na lang natin P, ang magiging distribution para ma-visualize natin, ito yung cross-section B at saka C. So the distribution is, diba, uniform. So 3D siya, so pag ganyan. And the value of this is P over A. Okay, so notice, importante na alam natin papunta saan yung ating normal force kasi it tells us also the nature of our stress, kung compression ba siya or hindi. So since nakuha natin dito compression na normal force, so compression din dito na normal stress. So ano yung P over A natin? That is just 150 over area na 10 times 4. So you will have 3.75. So this is PSI. Okay, so note that negative to siya compression. So pwede kong isulat as negative 3.75 PSI or yan. So P over A. Okay, and then due to the bending moment, so meron tayong bending stress. So ito ang ating section BC, point B dyan and point C dito. And then notice that remember that pag bending stress, magiging 0 sa neutral axis, and then maximum sa outer fiber. So, i-drawing natin, if this is the neutral axis, pag ganito siya, then gaganyan. Okay? Tapos, yung plane din natin. Okay? Diba pag ganyan? Okay. Now, ang values nito, this is, ang ating C is from, remember ang C natin from here, papunta dito ha, C yan. So, dito, MC over I, MC over I. Okay? Pero, tingnan nyo class yung nature ng ating bending moment. Pakuan siya clockwise. So, it means to say, dito na part, to the right of the neutral axis, compression siya. Nako-compress dito na part, while this one is in tension. So, ang drawing natin, pag ganyan. Compression dito, and then tension dito. So, kung lalagyan natin ng sign, this is negative MC over I, while that one is positive MC over I. Okay, so lagyan ko rin to ng PSI. Okay, so isolve lang muna natin what is MC over I. So, M natin is 750 times, ang C natin is yung 5 inch, di ba? Over, okay, yung I natin. Ano yung magiging I natin dito, class? Remember that our I, dito ko isulat ha, our I is 1 over 12 BH cube. Now, in our previous example, our cross-section is pa ganito. Okay, di ba? And if this is our bending moment, yung direction niya, ito yung B, ito yung edge. Now, saan dito ang, di ba, ang I natin dito is the moment of inertia about the axis of bending. Now, if this is our case, our axis of bending, saan ba yung axis kung saan tayo, kung saan mabibend siya due to this moment? So, of course, pag tinignan natin to, di ba dito siya yung moment natin, ang mabibend is itong X. Okay? So, if this is our X, yung perpendicular sa kanya, if this is B and this is edge, perpendicular sa kanya is edge. In our formula, yun yung ating i-cube. Okay? While, kung ito yung case natin, which is in this example, pag ganito yung cross-section, so this is, let's say this is our base, this is our height, which is, diba, 10 to. Then, ito is, 4. Ito yung neutral axis, then, ito yung Y, ito yung, let's say yan, Y to X, and then Z. Okay. So, ang bending moment natin is pag ganito ang direction, remember? So, saan dyan ang axis of bending? Ang axis of bending, of course, saan mabibend yung member natin? Hindi siya sa X, di ba? Hindi siya sa X. Mabibend siya, ang axis of bending natin is ito. Dito, when you apply this moment, magkakaroon tayo ng bending dyan. Okay, so therefore, if this is our axis of bending, ang perpendicular sa kanya, yung B ba or yung edge? Okay, so we have the B. So yung 10 ngayon, siya yung makikube sa ating formula. Okay? So that's why, ang formula natin is 1 over 12, magiging 1 over 12 times ang 10 cube. 10 cube times yung edge, which is 4. From that, ang makukuha natin na value is 11.25. Okay, so 11.25, this is PSI. Okay, so ibig sabihin, positive 11.25 tayo dito, while dito naman is negative 11.25 PSI. Okay? So, yan. Now, para makuha natin yung resultant stress distribution sa ating cross-section na BC, we have to add algebraically the individual effects of the stresses coming from the normal, load, and the bending moment. Okay, so in equation, that is sigma equals to sigma A plus or minus sigma B. Okay, so ang maximum natin, of course, na sigma equals to sigma A plus sigma B, right? And lagyan ko na lang ng value, that will be negative 3.75 plus 11.25 psi equals 7.5 psi. Okay, then minimum negative 3.75 minus 11.25, and that is equals to negative 15 psi. Okay, so negative 15 psi, so this is in tension to, and then this is in compression. And saan dyan yung sigma B at saka sigma C? Okay, so ang sigma B, dito siya banda, no, sa left side. So ang sigma B natin is yan yung value kapag i-add natin itong negative 3.75 tapos ito, which is ito dapat 7.5. So which is our sigma B. Then ang ating sigma C naman, nandito yung ating sigma C, so ang value niya is negative 3.75 plus yung negative 11.275, no? Kasi uniform man siya diyan papunta sa C. Okay? So this is our sigma C. So isulat natin, you have sigma B equals to 7.5 psi, and then sigma C equals to negative 15 psi. Okay? So, bakit ulit ito yung nagamit natin na formula? This is not applicable to all class. This is only kapag ang percent na stress sa ating section is axial at saka flexural. Now, nakita natin in our previous example na pwede rin na hindi lang yan yung present. Pwedeng meron tayong shear, normal force, mayroong shear, may moment, no? Pwede rin na may torsion moment, so that's very complicated kung masyadong marami yung percent na stress distribution. Okay? Now, kung ito-drawing natin yung resultant stress distribution, okay, so equals, isasum lang natin yan, so magiging itsura niya, class, is, okay, so if this is our neutral axis, so diba nung gi-minus natin ang eto 3.75 sa 11.25, plus natin, ang lumabas is 7.5, and that is tension, right? So draw tayo ng triangle dyan, hindi magre-reach sa ating neutral axis, and then another triangle here, so this will be copied there. Okay, so 7.5 dito positive, and then dito naman is negative 15. So it follows that ito ang direction tension hanggang na 0, and then this one naman is naging compression. Okay? PSI. Now, although hindi siya tinatanong, kung gusto natin kunin yung location kung saan 0 ang ating stress. So, let natin yan as x. And then, remember, this is 10. So, this is 10 minus x. So, by similar triangles, we have x over 7.5 equals 10 minus x over 15. So, you have 15x equals to 75 minus 7.5x. So, 15 plus 7.5 x equals to 75. So, x natin is 75 over 15 plus 7.5. And, isolve natin yung expression. Bakit hindi niya masolve? Ang lalabas dito, x equals to 75 over 15 plus 7.5. Bakit hindi niya isolve? $75 over 15 plus 7.5 equals ang tagal naman. Equals 75 over 15 plus 7.5. Ang lalabas dyan, class, is 3.33. 3.33 inch. Okay, so paki-check lang if yan yung lumabas din sa inyo. 15x 75. Okay. So, yan yung location. 3.33. Okay. So, this is our solution for problem number 3. Now, another solution pwede nating class gawin is i-transform natin yung given na loading to an equivalent loading kung saan i-compute na natin yung actual load. Ganito class, no? Parang, diba ito yung given. 50 dito, naka-act. 150, right? Wow. 150. So, 2 inch to 2, tapos ito, 5 inch and then 5. Now, pwede natin gawin, i-transform natin yung load. Diba ang sinusolve naman natin is yung actual load, tapos yung moment about the centroidal axis. Why not, yung 150 na galing dito, ilagay ko siya sa centroidal axis para maging actual load siya. So, ganito. 150. Okay, 150 pounds. But, to do that, kailangan natin i-take into account yung sa original, di ba may makakreate siya na moment about the centroidal, which is itong 150, pa-moment mo dito sa centroidal, and that is 150 times 5, right? Now, kung change natin yung 150, yung position niya, nilagay natin dito, kailangan natin ilagay din yung na-produce na bending moment sa original, which is ang direction papunta dito, di ba? And that is 150 times 5, and that is 750. Okay? So, pag ma-transform natin siya na ganyan, tapos, di ba, ang gusto natin is at section BC. So, pag-cut natin, automatic alam natin that the normal force dito is 150, and then ang bending moment natin is, kung ito papunta doon, clockwise, while this one, kailangan counterclockwise. So, 750. Okay? So, pwede natin yung gawin. And, yung mga susunod sa solution, same lang dito. Same lang dito sa dito. Nag-start tayo dyan hanggang sa end. Okay, so if you have any question, just comment down, and then I'll see if masagot natin yung question ninyo before the exam.